task 3, we had a slight glitch there with our technology, but we're back. Task 3 is to explain this table of elements. So what does it mean? What's going on? What's the position of the elements mean? What does that show us? Yes, we see them like this in a table, but I kind of want you to forget about that. And I want you to think about it more like a castle. And how would you behave and how would the elements behave depending on where you were in the castle. So this table has just under 120 different elements. And remember that an element is a pure substance. It's only made up of one type of atom. So I haven't split this into little boxes because really for this part, we don't need to know the individual little elements. We need to know what different areas of the periodic table mean. So let's take a look at the table itself. As Mendeleev and Lavoisier and John Dalton, they all put this table together for us. So we have groups, and they are numbered because they are the columns going down. So group 1 is the alkali metals, group 2 is the alkaline earth metals. Then we have no numbers really. Some periodic tables have some numbers, but really I want us to focus on this way of looking at it, which is most periodic tables. Then we jump to 3. This is group 3, group 4. I've not even drawn them in. Group 5, group 6, group 7 I have, and group 8 I have drawn in because we're going to talk about them. Now 8 is sometimes known as 0 as well, and you'll learn more about that in year 8. Now if you look upon it as a castle, I've got a little turret over here. I've then got the main part of the castle that we live in, and then we've got another turret with a very tall turret at the end. So let's take each of these now and look at what they mean, how they behave. So here we have the alkali metals. They are the most reactive group on the periodic table. They're the ones that if you were in that part of the castle, it would be major party animal stuff. They're all bouncing off each other. They will react with absolutely anything. And in fact, they're so reactive that they only exist in our lives as compounds. That means that they have to chemically combine with something else. So for example, in this, you may have seen in the classroom when we did this as practicals, and I put sodium, lithium and potassium into some water. This is sodium. Sodium chloride is table salt, but of course it can't exist just as sodium in my cupboard. We keep all of these alkali metals in oil in the lab, in our prep room. So this is chemically combined to chlorine to make sodium chloride. So you have an alkali metal in your house, on your chips, on your food, but as a compound. Another one, sorry I ate the banana for lunch, so it's not available to you at the moment. Potassium. So bananas contain the compound potassium. It's the element potassium, but in a compound in the banana. That one's done for now. If we then look at this group is quite special because it becomes more reactive as you go down. So you start with the elements at the top, they're still very reactive, but as you come to the elements further down, they become even more reactive until you get to the ones down here, which nobody has in any lab because they're so reactive. The alkaline earth metals, they're also quite reactive, so this turret of our castle is quite a happening place, but they're not as reactive as this first group, and we often use these ones in the lab to show chemical reactions. We've then got the main part of our castle, and that's because that's where we get all the metals from that we use in everyday life. So to make houses and cars and chairs and tables and various parts of tools that we use, including jewellery, we get all of that from this large area of the periodic table called transition metals. So they're everyday, they're not that reactive, and that's why we can use them in our everyday lives. Now you'll probably notice most of the periodic table is metals. These are all metals, 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 and then we get to this zigzag line. This is questionable. Some chemists would argue where that's exactly placed, but we'll stick it there for now. And then we move into this corner. The top right corner is the non-metals, so gases. So we've got lots in here. We've got oxygen and carbon and various things in there. But the first group that we're interested in are the halogens. Now the halogens, and my beautiful assistant is wheeling me something in. The halogens, you have lots of halogens in your house. You may have Savlon. That's got a halogen in it because halogens are toxic and they're poisonous and they kill stuff. So that's your halogen in there. There's a halogen in Dettol as well. It kills various germs and bacteria and microorganisms. There's a halogen in your toothpaste. Yeah, there's fluorine. These ones have chlorine in them, as does this one here. It's a surface cleaner. Any of your sprays, they have halogens. But your toothpaste has fluorine. That's a halogen because it kills anything in your mouth when you're cleaning it. It gets rid of some of the bacteria. So all of these are all group 7 and they're reactive gases actually. It's only when they're in substances like this as a compound that they're not a gas and they're safe to us. Now this group, unlike this very reactive group, this reactive group is the other way around. It's most reactive at the top, least reactive at the bottom. Whereas this one is least reactive at the top and becomes more reactive. And then we've got our final group 8. Group 8, that's the part of the castle you want to go to if you want to chill out and have nothing to worry about. Because this last group is the noble gases. And the noble gases are stable, inert elements. They don't want to react with anything. That's why you can have the neons and the argons and the heliums. They can be put into balloons and into lights and be hot and in the sun and nothing will happen because they're inert, stable elements. So that's a whistle-stop tour of this incredible periodic table. Let's think about it as parts and how things chemically behave rather than a complicated table of 118, 19 elements. So that's task 3. Right, task 4. This week I've set you 2 videos all about this amazing periodic table and how it ended up looking as it does now. All I want you to do is watch both of the videos and just simply decide which one sits with you best. Which one do you like the most? Which is your preferred way of learning about the periodic table? That's all I want you to do, is just watch both of them. You don't even have to write anything down. Just think about which one did I like watching the most and why. Just tell somebody about it. That's that task for this week. So as always, we finish our little science videos with science at its fluffiest and best. These little creatures, little organisms, are now a couple of days off, 6 weeks old, and they are just becoming funnier and funnier every single day. Oh, almost going to climb that there. So it's goodbye from me, and it's goodbye from these guys. They are having lots of fun. Here comes Mummy just to check it all out. Bye everybody. Enjoy this week's tasks.